So I study the dynamics of small networks, and these networks come from lobsters and crabs and other kinds of animals. So I do work on a much more reductionist level than many of the people here at this meeting. I was trying to remember when I first met him, because I remember being blown away when I met him. He gave a stunning talk at some meeting I was at, and then I got to know him a little bit, and I always remember him as having the most warm smile of any scientist I can think of, and he has this jubilant joy in science and life that I truly admire, so I've always been very fond of him. I think his work has been inspirational for almost the whole field of systems neuroscience, because he was one of the people who seriously took on the project of building bridges between different levels of analysis. And I think one of the major challenges in neuroscience is always to know how to go up and down between different levels of analysis. And he really took that problem to a very high level in trying to account for fMRI signals in terms and high-level behavior in terms of underlying neural mechanisms. So I really admire that, and he's also one of the most courageous scientists I've ever known. So early on, we worked on trying to understand how circuit dynamics arose from the interaction of cells and their synaptic connections. And we were probably among the first, if not the first, to seriously try and account for the effects of neuromodulators in terms of their cellular actions, and then again to try and understand how modulatory control would affect circuit dynamics. That was sort of the first stage of my career, and then that led me, for a variety of reasons, to start working with and collaborating with theorists. And so for many people, I was the person who was really known as an experimentalist, who had a very, very fruitful collaboration with Larry Abbott, and that was very instrumental in moving the field towards additional acceptance of that kind of collaboration. One of the things that Larry and I did is we built the first homeostatic models of intrinsic excitability. These were models that were intended to try and explain how a cell and networks could maintain their function over very long periods of time. And that early work led to later work that Gina Turgiano did and other people did on synaptic scaling. And now there's a whole sort of field that studies homeostatic regulation of synaptic and intrinsic excitability. Most recently, along the way, Larry and I developed the dynamic clamp, and then most recently, we've been studying animal-to-animal variability and trying to understand how tightly controlled all of the components of cells and circuits need to be for good enough behavior. And this was probably another real paradigm shift, because we started taking seriously the variance in our data and trying to understand it along with developing additional models. And so today, what we're trying to understand is individual variability in resilience to environmental perturbations, and trying to explain that in terms of the structures of underlying cellular and synaptic components. Well, of course they should study neuroscience, but it is both the best of times and the worst of times, to quote a long ago author. It is the best of times because new technological advances are providing us the opportunity to do experiments that we could never even dreamt of 40 years ago. And so that's the good news. The bad news is the young people are living in a very stressed world, and the future is a very ill-defined concept for them, not only in terms of their future as scientists, but they worry about the future of the planet. So we are all living in a much more difficult place, and that anxiety about the future, I think, carries over into the way they think about their futures as scientists and as human beings on this very challenged planet with this very challenged political environment. Yes, well, it's not only my president, it's lots of presidents. Exactly. So I really think that I hope that they would follow the joy of exploration, because many of them still feel that, but they're getting many, many, many discouraging signals from their world, and it's very sad.